Hey there! Lesson 32 time. I want you to notice something there about the binary. What just happened? It rolled over to the next digit, power of 2, which I think is a little bit interesting because today we're going to be talking about exponents and powers and kind of what it all means. Binary is built off of powers of 2. Each digit is another power of 2, represented by zeros and ones. 0 if that switch is off, and 1 if that switch is on. So the only on switch is 2 to the 1, 2, 3, 4 to the 5th power. 2 to the 5th power. All right. So what are we going to do today? Well, we're going to talk about what it means when we have an exponent that's negative. We're also going to talk about what it means when an exponent is 0. What do you do with that? And we're going to talk about when you've got exponents in the denominator, a term in the denominator. So pretty much that's it, and then we'll just apply it in different ways. But I want to show you why these rules are true, so you definitely should write down the proofs that I give today so you can kind of just go back and see, oh, that's why. And I'll keep reminding you of why these things are true so that you can sort out what it is that you're supposed to do on a problem. Now, in the book, they've got powers of 2, but I'm going to work with powers of 3. No, I'll work with powers of 2. That maybe it makes sense if I just talked about binary. All these 3 things have some type of meaning to them. You can try it on the calculator, but man, that's pretty lazy most of the time to just type things into the calculator. Yeah, plus it gives these long decimals rather than a fraction, then you have to go and change that. We know that this means 3 times itself. 3 times 3. But what in the world does that mean? 3 times never times itself? Is that just 0? Because 0 times 3 is 0. And then what in the world does it mean to take 3 to itself negative 2 times, right? What is the meaning of that? So let's back up a little bit and let's take those 3's, sorry, the 2's, power of 2's, and we'll start at 2 to the 4th, and then we're just going to run this down until we run into what seems to be a problem. 2 to various powers. So these ones are not so bad because we know we got 2 times 2 is 4, times 2 is 8, times 2 is 16. That makes sense. 2 to the 3rd is just one less of those, right? Or basically dividing by 2. 2 times 2 is 4, times 2 is 8. And then I'm going to do that one fewer times, except 2 times 2 is 4. And then 2 to the 1 is just 2. Then what happens here when I get to 2 to the 0? Well, one thing to do is just observe the pattern. Every time that we drop the power down by 1, what happens over here in this column is that it just drops in half. It's cut in half or is divided by 2. So 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. And I'm going to keep dropping that power down from 0 to negative 1 to negative 2, and we're just going to keep the pattern going. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. And what's 1/2 divided by 2? That's 1/4. Now if I kept going to the negative 3, to the negative 4, you divide this by half again, you get 1/8, and you're going to get 1/16. Now what I want you to know is when that power, 4, to the 4 was 16, to the negative 4 was 1/16. So in essence, what we're doing here is saying this is 1/2 to the 1, this is 1/2 to the 2, this is 1/2 cubed, this is 1/2 to the 4th. It gives us a sense of what a negative exponent means. A negative exponent means 1 over that number to a positive power. It's like, let's just put that problem now in the denominator rather than in the numerator. So if I switch this sign to the fourth. 2 to the negative fourth means 1/16. 2 to the third is 8. 2 to the negative 3 is 1/8. Okay, so that's one of our definitions today. We'll write this formally for a negative exponent. Let's generalize this and just call it x, because I could do this with 3's. X to a negative exponent n is 1 over x to the positive n. Makes it a fraction. Another way you could write this too is if you wanted to write something that was already normal, x to the n power, you could put it in the denominator, but then you would have to change its sign. Okay, so for whatever reason, if I wanted to, I could have written 2 to the fourth as 1 over 2 to the negative fourth, which is kind of dumb. That'd be 1 over 16. That's just 16. So these are our little rules for starters. This is the negative exponent rule. Both of them. They're just saying like, well, hey, what if this was the case? What if that was the case? If I'm going to change the sign on that power, I have to put it either in the denominator or I have to switch it back up to the numerator. I can do either one. See why we had the second version of that in a little while. So there's our first rule, just based off of this pattern of powers of 2. We can go down and we can get to negatives. Now, when we got here, we stopped and we said, well, 2 to the 0 equals 1. What if we were doing 3's? Well, 3 squared is 9, and 3 to the 1 is 3, and 3 to the 0 is... Well, the pattern would have been the same thing. If I go even bigger, 3 cubed would have been 27. And each time I drop down 1 power in the exponent, I'm dividing by 3. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. Which we can do the same thing with 4's or 5's or whatever we wanted to. The point here is that here's our second definition. What does it mean when we have the exponent of 0? Anything to the 0 power is going to equal 1. I'm going to prove that here in just a second, but you make sure that you write down that and memorize it and let it go deep into your soul, okay? Anything to the 0 power is 1. Proof time. Prepare yourselves. Okie dokie. 4 over 4 is equal to 1. Yes? Yes, nod your head. Thank you. 4 can be written as 2 squared. Okay, in the denominator there, 2 squared as well. Then using our little rule from right up here, if I've got something down here in the denominator, I can move it up here, but I've got to make it a negative. So this is also equal to 2 squared times, this one comes up, it becomes 2 to the negative 2. So 2 squared times 2 to the negative 2 is this, which is 1. Okay, using my rules for exponents, I got the same base, so I'm going to go the little addition rule here. That's equal to 2 to the power of 2 minus 2. And 2 minus 2 is 0. And we just trace it all the way back, and we see that, oh, wait, that was equal to 1. 2 to the 0 equals 1. That's a couple of different ways of proving to you that something to the 0 power is equal to 1. This is a handy-dandy one to keep on our back pocket. We'll use it every now and then to simplify a problem. Let me pause here for a minute and get myself sorted, and I'll be right back live and direct. Okay, here's the next thing. Cleaning things up a little bit. In algebra world, it is preferable that we write things, we put things in a form where you have positive exponents. So if you get something expressed like x to the negative third power, it is preferable that you clean that up by doing it. Or y to the negative 2, changing that to 1 over y squared. Oh, we make so fewer mistakes when we're dealing with positives and addition rather than negatives and subtraction. So there's one thing that is preferable to do is to clean that up a little bit. And definitely answers need to be written with positive exponents. For instance, you're working through a problem and you get something like y squared and x to the negative 3. It would be better for you to go y squared and then move that x to the denominator, change the sign to a positive value, y squared over x cubed. Okay, I'll be reminding you of that, and as I talk through problems, I'll show that over and over and over again until you finally get it. Would you please just help me out? Okay, trick question time. They'll do something like this where they want you to evaluate. They're going to give you what x and y happen to be, but it's x cubed and y to the 0. Now, your first inclination might be to do something like this and then plug those numbers in, but that'd be silly. That means you didn't learn something today, because we know that anytime you have anything to 0 power, it doesn't matter what you plug in there, it's going to be 1. So why confuse yourself by putting in a negative 3 and then thinking about what that means? Let's just call that 1, and then we'll plug in our negative 2 and cube it and get ourselves a negative 8. Trick. Okay, it's a trick. Anytime you see something y to the 0, you can treat it as 1. Treat it as 1. Anything to the 0 power is 1. Anything to the 0 power is 1. Anything to the 0 power is 1. Get it in your head, okay? Get it in your head. Simplify that right away. Don't put anything in there and get confused. Just say, that's 1. Here's another one to think about. We're going to leave that y be negative 3, but we've got this situation here. We've got a negative exponent, and we got a positive y to the imaginary 1 that's sitting there. So what can we do with that? Well, we can use our rules for exponents and do this, combine it all into 1, and say negative 3 plus 1, which is equal to y to the negative 2. We said already that is not preferable, so what are we going to do with that y to the negative 2? Well, that 3 is going to stay put, but that y is going to drop down into the denominator and become a positive exponent. That, again, is the preferred way to write answers, is with positive exponents. Right there, we used this rule right there, didn't we? We took that y to the negative 2 and we dropped it down and changed the sign on it. That's something important to do. Got some things for you to try here. Can you see these? I'll read them, write them down, hit pause, try them. This is x to the 7th over x to the 3rd. This is x to the 3rd over x to the 7th. X cubed, x to the 3rd again, over x to the negative 7th. And x to the negative 3 over x to the negative 7th. I want you to try to write that answer with no negative exponents. Okay, so hit pause, try them. Okay, here's what they each look like with positive exponents. X to the 4th, x 1 over x to the 4th, x to the 10th, and x to the positive 4th. If you didn't get those, we need to talk about that in class. I'll put one more up here. I'm going to talk really fast. Hang on. Don't worry about how many letters they put up there. Deal with each letter separately, each variable. Here's the problem. I need the A's together and the C's together. It might be helpful to move everything to the numerator and deal with it. If you did that, here's what I get. C to the 5th and C to the negative 2. I can then combine that stuff. A to the negative 2 and 5. C to the 5 minus 2. And finish that off with A cubed C cubed. Check my math there, but I think I did that one all right. Lots of different methods we can do to get these things so they're a little bit nicer to play with. But there's a good starter. Ask some questions when you come to class.